Hi, hello? Can you hear me? Is this projecting? Is this projecting? Yeah? Okay. Hello! Wow, can you guys see me over there? There's a big pillar in the way. If you guys want, there's some nice seats over here that are much more comfortable. Wow, I am so impressed at how many people have turned up tonight. Thank you all so much for coming. I know we want to be respectful of your time, so we're going to start on time. The beginning part is just my spiel, so pardon if the people come in a little bit late. I'm Michelle. This is the MLUX Machine Learning and User Experience Meetup. Is anybody in the wrong place? No? Okay, cool. Yeah, thank you all so much for coming, for taking time out of your day. I know after your long day at work to come and spend time with us. Thank you to all the Salesforce folks who have helped make this possible. This is absolutely amazing. This is all the Wi-Fi information. No software. Username is guest. Password is HYXU, all capitals, CPSO, for those of you who can't read that. And we do have a hashtag. I know, it's a big deal. It's hashtag MLUXSF. So if you feel so inspired to take a photo of me while I'm out here and put that on LinkedIn and be like, I'm having a great time here and learning so much, like, that would be cool. And if you do have any feedback for us too, you can go to bit.ly/MLUXSF or come see me and be like, hey, I have a really cool idea for a talk, or I want to sponsor something. Like, that would be awesome. Like, I really want to hear your feedback. This community just keeps on growing and growing, and it wouldn't be possible without you guys and your enthusiasm. So thank you. So let's get started. A little bit about logistics. If you need a restroom, they are out there to the left and then to another left and then another left. So they're like there, but you can't go through that wall. And we did some networking. Yeah, you guys made some new friends, met some cool people. Yeah, awesome. I'm going to do a little bit of a spiel about what machine learning UX is. Then we have some really amazing lightning talks lined up by Salesforce. I am super excited about these. We not only have a UX team, UX design, UX research, we have a data scientist, and we have an ethics discussion. What? Like that's like the dream talk lineup for me. I don't know about you guys, but all in one night, this is going to be amazing. And we also have a Q&A panel planned too. So I have some pre-prepared questions, but we'll leave some time for other questions. So think about questions while they're up here. And it will leave you time for more networking, more food if you didn't get enough food, because the food out there is really amazing. Thank you so much, Salesforce. And then the event ends at 9. Cool. Sound good? Any questions? No? Okay. So hello, I'm Michelle. If you can't see my face all the way back up there in the nosebleeds, this is what I look like. I am a graduate student over at the UC Berkeley School of Information, where I study the intersection of data science and user experience. Before coming to grad school, I worked as a computational neuroscience researcher and then as a UX designer and researcher. So I'm trying to combine both of them, and I think it's working because this meetup seems to be pretty successful. So yeah, seems to be going well. Yeah, nice, it worked. Although I'm up here giving the little intro and spiel and you get to see me, this would not be possible without our amazing volunteers, the folks who checked you in, both at Salesforce, but also our MLUX volunteers, Will, Maddie, Allison, Olivia, and special shout out to Nikki, who just set up our YouTube page. So what? Thank you. If you want to volunteer and you're like, oh, you should be doing this, but you're not, there's only like one of me, so I would love extra help doing that. So thank you for Nikki for taking that extra. There's Nikki. She's great. She was also our SAP.io sponsor last month. Also, big shout out to our Salesforce team who helped make this happen. That's James and Molly up here. You'll be hearing from them. But also Lana, who's not with us because she went home. But thank you for actually making that happen. I also wanted to plug that this is a fellowship project through the Center for Technology, Society, and Policy. And if you don't know what that is, you should. It's amazing. So they're a really cool interdisciplinary research center at UC Berkeley, which fund projects that are geared towards getting the latest and greatest tech, society, policy kind of projects integrated with practitioners. So this is one of their projects in conjunction with the Algorithmic Fairness and Opacity Working Group. So the Algorithmic Fairness and Opacity Working Group, both their websites are up here. They are a working group of researchers at Berkeley who are trying to research what is fairness in algorithms, what is opacity, what does that actually mean for us in the field, which is really cool. The fact that they saw this meetup and wanted to fund it, they pay for the meetup.com subscription, which is a lot when you're a grad student, so thank you. Highly recommend checking out their website, ctsb.berkeley.edu and afog.berkeley.edu. Or come see me if you're like, oh, those sound really cool and I want to work with them. Like, they're great, so thank you. Real quick, how many of you, this is your first MLUX meetup? What? Oh, wait. I have to take a photo every time I ask because it's really cute. There's like less and less every time. Okay. How many of you? Raise your hand. This side? Cute. Okay. This side? Cute. Okay. Awesome. There's less and less every time, and that makes me really excited because you guys are coming back. Great. So this is how I explain what machine learning and UX is. And the reason why we call it machine learning and UX is because data science and UX is not as fun as an acronym as MLUX. So there we go. So when I say that I study the intersection of data science and user experience, I study how data drives design decisions. So like how can we use data science, statistical inference, kind of understanding about what the data is telling us about the users to actually make informed design decisions, but also how do we design for the data science? How do we design for machine learning? How do we know like what the models are telling us? How do we give that in a cool visualization output? How do we actually design to get the right data? Like what if we have a whole segment of our population that we're not measuring? How do we design a way to get that data, right? So it's kind of the whole part of that. And I try to find talks that are geared around that in different aspects. So also I want to say that UX is not just visual design for all the UX practitioners out there who are like, I'm not a visual designer. It's also UX researcher, information architecture, copywriting, much more, as well as data science. It could be statistical inference like p-values. That can go really far. You don't need a like neural net to make some of your decisions. And artificial intelligence, data analysis, and all that stuff. So this meetup is geared around talks that kind of span both spheres. It can lead to really cool products. Some of my favorites are the Pinterest auto seed algorithm. So as you go through, you enter something and you're like, oh, the search results aren't right, but this is kind of closer. It can actually update that. So that's a really cool user experience that happens thanks to machine learning, computer vision. Or things like autocorrect or autocomplete, or the my favorite is the quick draw auto draw case study where they get a lot of labeled data really fast and then can build more products off of that. So we are a professional meetup group. We have over 1,000 members. Whoa! Yeah, we did it. Yeah. Nice job. It wouldn't have been possible without you. We actually have 1,014. That's a lot. This is the best way too to stay in contact with us or know when our upcoming events are. And thanks to Nikki, we have a brand new YouTube page. Whoa! So this event is being recorded, and we'll put it up on that YouTube page as well as Clara Labs, which we did back in January. That's actually under playlist because they uploaded their own, but it's all up there. So if you want to see our past talks, because I know that we also have folks in different cities who watch this too. So yeah, so I was going to academic conferences and realizing there were folks who are practicing in this, but there's not like a really good professional community space around this. So that's kind of how this meetup got started. In order to do our vision, which is to create a collaborative environment between UX, data science, and everyone in between. And we aim to organize a community that helps foster cooperation, creativity, and learning across disciplines. And our goal is to create a space to discuss human-centered machine learning and to share ideas and resources. So that's what we try to do. There's a lot of tech talks that we have or panels. We also will do networking nights and everything too, which is kind of what we have planned for next month. But just a look back, we've worked with Quid, Autodesk. Oh, there's Quid. That's where we started. We were only like 60 people. And then Autodesk, we were like 200 people. And then Clara Labs, we were a full house. We actually had to kick people out. So I'm sorry about that, but we recorded it. And then Noodle.ai at SAP.io was full too. We were over capacity, and same with tonight. So it's really exciting to see all these folks who are interested in this, working in this, coming together and build this community. And I really hope that you take the time to meet other cool folks who are working on really cool things. Share those connections, share your best practices. Come talk to me if you want to host a talk, because we would love to hear about what you do and how you do it. Speaking of, let's do an icebreaker. Yeah, we're going to meet some people. So we're going to take 2 minutes, turn to someone who you haven't met before, just talk to them, these are some starter questions, and then we'll talk to someone else too. Cool. All right, if you haven't already, switch, talk to someone else. All right, not to cut it short, I know. Hey, everybody. Hi. Hey. Yeah, should I do it? Okay. Okay, everybody, if you can hear me, clap once. If you can hear me, clap twice. If you can hear me, clap 3 times. Awesome. Thank you. Yes, I teach undergrad, so it works really well. So sorry, thank you. Thank you for bearing with me. We just have a tight schedule to get on, and I know you guys came here to meet friends and learn about cool talks, but there'll be plenty of time to meet friends afterwards. So you guys meet some cool people? Yeah? Yeah? Oh, awesome. I'm so glad to hear that. It's already a success, even if we don't hear talks, and we get to hear talks on top of it. So I just want to do a really quick plug. Machine Learning and UX Meetup cannot happen without you. Like, we have been so fortunate to have so many amazing community sponsors kind of step up and really be able to sponsor us at venues like this, give us amazing food. If the venue is less important, but the most important thing is really interesting speakers. So if you are a UX designer working in machine learning, if you're a data scientist solving problems around experiences, if you do research into perceptions around machine learning and data science interfaces, if you blend ML and AI seamlessly into your user experience, we would love to hear about how you do it and what problems you face, any best practices. Because remember, we're trying to grow this community of practitioners who are building off of each other. So please come see me. You can find me on meetup.com/MLUXSF and meet up me directly. That's probably the best way to get in contact with me. But we're looking for talks for the rest of the year, so come say hi. And if you do have a venue and sponsor, we would love to also talk with you. I know we're growing too. We could also do smaller meetups, up to you, whatever you want to work with. We need people who would like to give talks. We also need volunteers, no MLUX experience required. And we also would love your feedback. Like I mentioned, you can either see me directly or fill out the bit.ly/MLUXSF. And you can contact me via meetup.com. This is really the best way to stay in contact about what our upcoming talks and events are. So the URL is meetup.com/MLUXSF. Okay, that's all the talking that I think that I will be doing for a little while. I wanted to turn it over to our amazing Salesforce sponsors. So thank you so much for listening to me. Now the fun part. So.
Thank you, Michelle. All right, good evening, everyone. My name is James Lewis. I'm a UX designer here at Salesforce. And at Salesforce, we like to start off presentations by saying thank you. So thank you to Michelle Carney and the MLUX volunteers. Thank you to all the Salesforce staff volunteering here as well tonight. And most importantly, thank you to all of you in attendance and for being part of this community. We're really excited to be hosting tonight. So a quick overview before we begin. You might hear a lot about Salesforce Einstein. That's the brand name for artificial intelligence and AI here at Salesforce. And it's Salesforce Einstein is really artificial intelligence for CRM. So that's customer relationship management. And the idea is that Einstein makes our customer success platform, which is marketing, commerce, service, communities, sales, a whole bunch of stuff, smarter. And businesses can predict their customers' behavior, and in turn, the customers get the highly personalized, intelligent experiences they expect. And Einstein has made it AI a reality for businesses, allowing them to access the power of machine learning without having to develop an end-to-end platform on their own. And currently, Einstein platform is powering over 1 billion predictions per day to end users on our platform around the world. So, enough about that. For our agenda tonight, I'll be speaking with Mahar on designing declarative machine learning experiences. We will hear from Challenge Masakera, a data scientist, on our automated ML system. And Kathy Baxter will be telling us how to build ethics into AI. And then we ask that you hold off any questions until the end. We'll do a 20, 30-minute Q&A with all the panel. All right, are you guys ready? Let's get started. Woo! All right. Are you ready? All right. Let's hope I don't drop an F-bomb. I'm getting a little nervous here. It's been known to happen, but I'll keep it clean. All right, so designing declarative machine learning experiences. So what is a declarative experience anyway? It's point and click. It's not code. It focuses on what the user wants to accomplish and not how it's built. And it allows for easy customization of UIs, of data, of business processes, and apps. So some examples from the consumer world that you might be familiar with are like Squarespace, where you can build a website without HTML or CSS. It's drag and drop. And SurveyMonkey, which allows you to create a survey with complex logic without having to code it in. And so those are both declarative experiences, and that's what the type of thing we're talking about tonight. And at Salesforce, we think of the tools we provide our developers and our Salesforce administrators, and I'll go into that a little bit more later. We think about the tools on a spectrum from no code, so declarative point-and-click tools, to low code and full code. And Molly and I will be talking about designing declarative UX for 2 different Einstein-powered apps on the Salesforce platform. The first is what I work on called Einstein Prediction Builder, which is currently in pilot preview. And it lets users create binary classifications, so yes, no, true, false, with a corresponding likelihood score, as well as regression predictions, so predicting numbers. And you can answer questions like, which clients are most likely to cancel their contract? Who's likely to leave my service? Or how much is someone likely to spend with me next quarter or year? So that's kind of the idea of what we're talking about.
And the second product is what I work on, which is Einstein Bots. I hear a lot of you are really interested in chatbots. So Einstein Bots allows Salesforce admins to build chatbots for customer service that can handle simple tasks, and we use natural language understanding for intent recognition when chatting with a customer. I'm going to try this clicker because I never get to use them. So James and I work on 2 fairly different products. We actually didn't know each other before Michelle approached us about doing this meetup. So we were like, well, we should give a talk. What can we talk about? And we discovered that there were quite a few similarities in what we were trying to tackle when designing like these declarative machine learning experiences for non-technical users. And so like 3 key themes that we found around our work were language, mental models, and processes. So those are the concepts we're going to talk about today. And let's start with language and terminology. Clearly, your users and their context should help you determine what language you're using within your product. At Salesforce, we have a number of personas that we design for. 2 that are important tonight for us are our Salesforce admins, who are in charge of configuring and managing kind of the day-to-day operations of Salesforce for their company, as well as developers, who are the ones using code and creating customized apps and customizations for Salesforce. So for these admins that we are designing for, machine learning comes with like a huge number of new terms that they need to learn. And this is in addition to like a lot of Salesforce terminology. And in my case, chatbots also have additional industry-specific terms. So how do we help them address like this deluge of new words and concepts that they need to learn and then work with? In Einstein Prediction Builder, rather than using the term training data, which a lot of you are probably familiar with, they framed the selection of training data in terms that are already familiar to Salesforce users. So they've gone within the Salesforce model. In this case, a record is a database row within Salesforce. So we ask, which records should Einstein use as examples? In bots, we actually went a slightly different tack. We chose to use industry standard terminology that relates to chatbots. So we use words like entity and intent, even though it's a lot more technical than we would normally want or choose. But when speaking with admins, they said because chatbots are like a whole new thing for them, they would end up doing a lot of searching online anyways. And so using terminology that they can easily find and find a lot of references for was going to end up being easier for them to do. But what we did to try to mitigate that choice is to introduce new terms via like the actions or the goals that they want to get out of that. So instead of just dropping a term like slot, we say in our UI, save answer to slot, and you start to have an idea of like, okay, this is kind of like a variable. This is something that's saving information. Just by seeing that, you start to understand what's happening behind the scenes. So with language, the big point we want to make is simplify when that's possible and give context as much as you can to clarify what's going on. And what that does is it helps build the mental model of what's going on for your users, which is what we're going to talk about next. So with bots, the mental model of what that is really develops out of a mental model of a conversation. It's a back and forth between two or more parties, and in this case, one of those is a bot. And the back and forth is pretty simple. You know, someone asks a question, you get an answer, or vice versa. And it kind of just happens smoothly. It's back and forth. And that mental model is pretty simple. You know, you think of it, oh, I need to know when to say something, and I need to know what to say. And that's really the basics of it. And that all holds up until you're in this really, until you're in situations where suddenly it like doesn't feel easy, like a bad first date, or you're learning a new language and everything is a lot more difficult. And at that point, you start to realize that there's a lot of hidden steps in that mental model that you just don't think about every day. You need to know the language. You need to understand what someone's actually saying. You need to recognize what they want out of that, respond in the right way when there's so many different options, and there's always mistakes that you need to fix. So it's not quite as simple as it first seems. And we need to handle all of these steps within the UI of our bot builder for our admins who are new to bots. So how do we tackle that? Is kind of divide up what we're doing and try to stick to the mental model as closely as possible. So in this case, natural language understanding is really what handles the when to say something. And then we provide this declarative interface to tackle what to say, because the admin like has to specify that for the bot. And the idea behind that is like we're keeping the right level of abstraction to maintain that mental model of the user, that really simple what to say, when to say it, but fit all of those little pieces into that framework. And in the case of builders, like for us, we're building a bot builder that allows somebody else to build other things that we can't control. So designing for that has important implications and has an effect on how they understand that whole process, in this case, machine learning, because it communicates what your product can. Ooh, I'm not talking close enough to the mic, am I? It not only communicates what you can do, but it also communicates what your product cannot do, which can be really important in a new field. Like our Salesforce admins might have had experience with like a dumb bot, like a rule-based bot, something very simple as a consumer, but they've also probably heard about K and might have no idea like where on the spectrum a Salesforce bot would be. They might be making assumptions about like what that is and how a bot on the Salesforce platform would learn. And there's this like sweet spot in the middle, right, where you have a bot that can learn from all of this data that we have in Salesforce, but where there's a lot of guardrails on what it can do. We're designing for customer service bots, as I said before, so we want to have a lot of guardrails. Companies have brands and brands to uphold and like voice and tone. So we start to demonstrate those guardrails through our UI to uphold this mental model. And in our pilot, that takes the form of surfacing really only 4 main actions within the bot builder itself for what it can do. It can send a message, it can request information via a question, you can run a script that creates or accesses Salesforce data, and you can also follow process rules like logic, if then. And so when an admin who has really no idea about the capabilities starts to see what options are available, it starts to clarify exactly what your product can and cannot do and start setting up those boundaries for them so that it can start understanding that process. So the key I want you to take away from that is using constraints to help shape the mental model of your users, because it will influence how they understand that process. And James is talking about process.
All right. Processes. So data scientists typically have expert knowledge of algorithms and all the way they can manipulate the data to get their end result when they're building a bespoke predictive model. So two different data scientists might come to similar results when trying to solve the same problem. That was a tongue twister. But they'll probably get there differently. So how do you take those diverging complex paths and simplify them down to high-level logical steps for a user who's new to machine learning and trying to build a model? In Einstein Prediction Builder, we've broken it down into 5 main steps. So selecting the data, filtering it, selecting examples or the training set, building the model, and then reviewing the results and going forward. So I'm going to show you a preview of a pilot or beta build of Einstein Prediction Builder. It's what we're using to test with our customers, and I'll show screens of what's been shown publicly. So when officially released, there'll be some UI changes, there'll be some improvements, and there's a few things I can't show you, but it'll be a good preview of some of the concepts we've been talking about and what's to come. So let's imagine you're a Salesforce administrator and you're building an online reservation app and you want to predict if someone is actually going to be a no-show, even though they've just made a reservation. In the UI, the user starts by giving the predictive model a name. In this case, it's no-show prediction. And they select the object that has the requisite data. So in Salesforce terminology, an object is essentially a relational database table. They then select the field, also known as a column, that they want to predict. And on the right-hand side of the UI, we have some questions and answers that we've found during usability testing that new users had. And so we're trying to preemptively answer them because they're new to machine learning. And we want to kind of take them hand in hand and guide them along each step. So then we ask the users to confirm the fields used to make their prediction, and we can automatically grab that from their Salesforce database. And we're doing things a little differently here by asking our admin user to actively deselect fields they don't want to include in the model. And the idea is that our AutoML system wants to look at everything it can and then be able to drop things that aren't relevant and keep things in that are. So we're focusing on asking the user to remove fields that they know contains irrelevant data. Sometimes it might be historical, might not be stuff they want to use, or data that might violate regulations or internal rules. Like you don't want to include gender often in predictive models or race. So the next step is filtering, which will let customers focus on specific regions, like customers only in North America or Europe, or perhaps customers belonging to a specific unit. And this makes the model more accurate and helps the Salesforce administrator tailor it to their use case. And then we ask them to set examples, also known as training data, which Molly mentioned earlier. In the pilot version of Einstein Prediction Builder, records or rows that have values will be used in the training set, and records without values will be put in the scoring set, so they'll get new predictions. Then we ask the user to review the settings in the model and click build, and then it goes. It takes a few hours. There's a lot of data to go through and a lot of models to try. And then once it's finished, this is what I can't show, but the user gets their results in a model report, and we're calling that a scorecard. And so this isn't included in the public screenshot, so I can't show it to you. But the idea here is to give the Salesforce administrator insight into the quality of the model and which fields were highly predictive, and really explain in their terms how good the model is. And so they can decide to go back and make changes, or they can put it into production and start experimenting with it. So that's the pilot walkthrough. My takeaways are, with process, think about abstracting and grouping steps when possible, and break up tasks in the smallest steps for the user so they can focus on one thing at a time. So we looked at Einstein Bots and Einstein Prediction Builder, two different machine learning products with similar considerations when designing declarative UX. So the language used, the mental models of the users, and the processes they go through. And that's it for me and Molly. Thank you very much. So as a friendly reminder, we'll be taking questions about this at the end of the Q&A. And next up, we have Challenge Masakera.
Thank you, James.
All right. Yeah, we'll put you there, and your time's right there. Cool.
Good evening, everyone. My name is Challenge. I'm a data scientist for Salesforce Einstein. I'm going to be talking about our automated machine learning platform because we don't have enough data scientists in the world to solve all the problems Salesforce has. So a bit of background, as I said, I do data science. So I do the ML part of the MLUX, and it will be pretty clear based on my slides compared to James and Molly's. Before that, I did a master's at Berkeley, Information Management Systems. Yeah. Yeah, there's like a lot of us. Before that, I did business intelligence consultancy. So today I'm going to talk about three things. First, what are the data science issues for a multi-tenant software as a service provider like Salesforce, where you are a B2B, not a B2C? Secondly, I'm going to talk about, just give an overview of like what are the AutoML services and what it looks like and what we provide and how we bring this all together. Then lastly, I'm going to talk a bit of, about the challenges of building an AutoML. So first, the data science issues for multi-tenant software as a service provider. And when I say multi-tenant, we're talking of a business that offers software to other businesses like a B2B. So firstly, like if you ever build like a machine learning application, if you ever tried doing ML, usually you're trying to solve one specific business use case. A good example is like if I think we all use Amazon, like they're trying to do product recommendation. So for you to do that, or like how you think about it, like all the users of that system usually do the same thing, like how they log into the service, how they go through their purchase decision. So from like a data science perspective, you can like easily like discover or like figure out what your features are. And by features, I mean the input to your data science model. And as such, if you are a team of engineers and machine learning architects trying to build a machine learning app around this, you can define what the data points are and what the schema of the data looks like. So like when you build machine learning apps, like they're like sort of variations of how you do it, but it usually boils out to something like this. First, one, you need to think about what's the specific business use case you're trying to solve. Secondly, what the data looks like, you do your, one of my favorite things, ETL. Then after that, you get into like what's usually the cool stuff, doing the modeling. Then after that, you evaluate how your models are performing and evaluate whether they solve the business problem. And then if not, you go back, then you deploy it. And it doesn't end there. You have to go back and figure out how to improve that machine learning application. So when you get to Salesforce now, our customers or our businesses, so for us to be able to provide machine learning apps for each and one of these businesses, we would need to have a specific team working specifically on each business problem. For example, Uber is one of our customers, and if we wanted to do lead scoring, which is predicting whether a sales lead will convert, would have to need like 3 data scientists working specifically on Uber data, understanding what it looks like, what their sales process looks like, and then building that machine learning algorithm and iterating over it over and over again. If we decided to say, now we want to do what's called opportunity scoring, how much this opportunity might cost us, we have to hire another set of data scientists working specifically on that machine learning problem. And let's say we get another customer, AXA, and they want the same thing. And it goes on. And even if we say, hey, let's hire all the data scientists in the world, we'll still not be able to solve all the machine learning problems that our customers need. So now I get into what we call metadata scientists. So the way we thought of it is like, how can we do metadata science, as in like teach computers to do data science? Some of you might be asking, so why can't we just build one super awesome global model that solves all these problems? And there are a couple of reasons to that, but like a lot of them, the main 3 are like, one, privacy. Our number 1 value is trust, and our customers trust us with their data. And they don't want, some of them don't want their data cross-pollinated with other orgs, because some of them may be competitors. So even though it might theoretically make sense for us to mix their data and build a global model with all that, for them, they don't think it's a great idea. Secondly, the business use cases are often different. Our customers are manufacturers, retailers, hotels. So even if they all want lead scoring, because their processes and how they do their businesses, it's different. We can't really just throw one model at that, even if it might have some good output. And even if they are in the same industry, usually you find that businesses, they all have their own little internal tweaks that they do to suit how their company performs. Thirdly, one of the great things of Salesforce is platform customization. If you use Salesforce, you're able to change the way Salesforce looks and what the data that you can put into Salesforce looks like to match your business needs. So going back to the example that James showed, there was like an object called reservation, and it's a custom object that you can just create on the fly and start adding data that works for you and for the particular business use case you want to have. And we also have standard objects which are present to every Salesforce customer, but you also have the ability to add new custom fields which more specifically tuned to what you need. And often or not, those are the ones that sometimes are very predictive. So what we wanted to do is like, this is a Titanic data set. If you have tried to do machine learning or taken a machine learning class, you might probably have been assigned this to like, so this is a very simple problem. Given the Titanic data set, the passengers who were on Titanic, can you predict if somebody survived or not? It seems like a simple problem, but like once you start doing it, it's very complex. You might get an model, but oftentimes it's not that good enough. So you have to go through this iterative step of trying to tune your model, trying to figure out like, out of all these columns, is sex a good thing to use into the picture? Is the cabin, where the passenger was in the cabin, is it also a great thing to do? So the next thing, what we thought of, like using all the great like UX that James and Molly showed us, we wanted to go mostly to a low-code, no-code kind of way, where you just give us the input of what you are trying to predict, which James showed, and we do all the magic behind the scenes, like which models to select, which features to use, and you just get the predictive outcome, like with the scores or whether somebody survived or not. And you get all your beautiful zeros and ones just there. Now I'm going to talk about just an overview of what our AutoML platform looks like. This is all like something that I've showed before, but like basically it's mostly three concepts. One, what are the sources of information that you're getting? What is the user input through UIs? What are our data sources? Then we have our the data pooler, the data prep, solves all your ETL problems. Then we have the good stuff, the modeling and scoring service, which will actually build the models, deliver scores, and deliver predictions. And it's all within the normal like control systems. We can schedule how often we want to train your models. And also, we have model management so that we can retrain new models and we check if the new model is better or worse. I'm going to zero in on like the most beautiful part of this, which is the AutoML platform components. If you have done machine learning, you're going to, and let's say you've done Titanic and it works, you're happy with it, and you're like, oh, now I want to do something else. You're going to have to do the same four things. One, where's the data? You extract the data, you start choosing which features again. So from like our user's perspective or like from our perspective, it doesn't make sense for us to be writing a billion scripts that do all this. So we have to think of like how do we automate all these steps so that you can get automated feature extraction, which chooses the fields. Like even though you can say, hey, I don't want to use these fields, but like out of all those, we also do automated feature selection, looking at the correlation, all the statistical analysis that you need to do yourself manually to think which features work. Secondly, we have the transformation plan. The beautiful thing about Salesforce and Salesforce data is it's really very rich in metadata, so we can do automated feature transformations like, oh, this, let's say a field is age, we know it's a number. We can do like basic, like standard transformations like you do normalization on numeric fields, you do bucketization, and any other cool stuff. Then thirdly, we do automated model selection. By that, usually when you're working on a team on a problem, you have somebody trying one type of machine learning model, whether it's a random forest, it's an SVM, and they keep try tuning it. And with our platform, it's all automated. It automatically tries a bunch of machine learning models depending on the output, whether it's a classification or a regression or like it's a deep learning, and picks the best one and fits that for the data. Then it just wraps it up and writes the data into the final output and writes it to a location where our customer can use it. So now that we have the good stuff, we have to think of like how do we productionize this in real life. Usually, like once it sounds very simple to productionize something, but once you try to do it, it's very complex, and you find out that most of the time you spend more time trying to just get the thing into production than actually writing the machine learning code. So we had to think of like how do we, since we are building all these hundreds of thousands of models, how can we parallelize processing? And we managed to do that using Spark. We also do cool stuff like building models to predict how much resources we need to use for a particular machine learning job. And we also have bots to like automate boarding DevOps stuff. And you can also like, if you want to run jobs from your phone, we have the ability to do that. So what Einstein AutoML offers is like, it's a personal data scientist with no boring ETL. You don't have to worry about extract, transform, load. And what we really wanted to provide value is like, you don't need a PhD to do machine learning. We're going to remove all the complexity from that. We'll do all the automated stuff. We'll give it to you out of the box. And you can easily get from no machine learning thing through point and click. We build the model and you get it into production super fast. Then lastly, I'm just going to talk about like what are the challenges of building a machine learning and automated ML. Well, firstly, it feels like it's low-hanging fruit, as in like, oh yeah, you can just like throw a bunch of models at it and it'll fix it. But like without like sort of having to figure out like what exactly is the declarative input. because the input determines the output. So if you can't think of like what's a great input structure that can solve all the machine learning without having to override the user with so much complexity, it becomes hard. Then how do you think of like understanding all these varied use cases and build something